In this class, now I am going to explain you one problem. Now before going to learn the solution of that problem, now I am requesting you to subscribe, like and share my channel so that my classes reaches to many people. Now let us see the problem. Find the minimum area of a triangle. Find the minimum area of a triangle formed by a line passing through a point A comma B with coordinate axis. So this is the given problem. Now let us see whose solution. See, now draw the rough diagram. So for this problem, this is x-axis and it is y-axis. Now this is the given line. I am representing with dotted dots. Now on this line one of the fixed point is given whose coordinates as A comma B. Okay. Now here this is origin. This line is intersecting x-axis here, let it be capital A. Now it is intersecting y-axis at one point, let it be capital B. Now about this point A comma B, rotate this line like this. Okay students, actually this line is made a triangle with coordinate axis, that is AOB in this figure. Here, this is the triangle formed by this line with coordinate axis. If this triangle is fixed, then we can say area of this triangle is 1/2 base into height. But here, about this point A comma B, see, if you rotate this line like this, changes will come in the x-intercept and y-intercept. Am I right? About this point. So what do? So fix this ends of the line in your hand like this, rotate like this. Changes will come in the x-intercept and y-intercept of that line. Now if you keep on rotating like this, so automatically area of this AOB triangle will change. Many triangles will form if you keep on rotating like this. So here what we require, the minimum area of a triangle which is formed by this line with coordinate axis. Many more triangles will form now. Among all that, what is the minimum area of the triangle? Okay. So to learn this solution, here we people are going to use this coordinate geometry concept and differentiation concept. Okay. Here x-intercept of this line is not given. So I am considering as small p units. Y-intercept small q units. Okay. Right. Now if x-intercept is given, y-intercept is given, as we people know that, so whose equation is x by p plus y by q, now which is equal to 1. This is the equation of this line. Okay now but it is passing through a fixed point A comma B now. Now replace this x by small a by p, replace y by small b by q, now which is equal to 1. Okay. Now hereafter write the area function because changes are getting in x-intercept p and y-intercept in q, so that p and q are here variables. So let us name the area of AOB triangle be capital A. Area of triangle AOB is equal to, let it be capital A. Now which is equal to 1 by 2 small p into base, height q, square units. Okay, but this is not fixed. Okay, p is a variable, q is a variable, you know that, right? Now thereafter, so here make q as subject from this. How do you make q as subject? Transfer this a by p to the right side, so that here you will get b by q, which is equal to 1 minus a by p. Okay, now hereafter, okay, take cross multiplication. B by q, which is equal to p minus a by p. Now reciprocal on both sides. Q by p, which is equal to p by p minus a. Now transfer b to the right side. If you transfer b to the right side, what do you get for q? Q is equal to b into p by p minus a. This is q. Now replace this q by this. So that what do you get for a? 1 by 2. Tell me students, here p is there. Here q value is bp by p minus a. Now simplify this. If you simplify this, here p into p, p square. Okay, now b into p square by 2 of p minus a. What is the area of the triangle? B into p square by 2 of p minus a. Okay, observe that here p is a variable. Okay, so in the next step we should make this area as minimum. This area as minimum. We need minimum area. So for that, what I am doing here, I am differentiating this area function with respect to a variable p. Now that is dA by dP. Now which is equal to, now it is looking like u by v, no? Now apply the u by v rule. So in u by v rule, what do we do? First we write here v, 2 into p minus a. 2 into p minus a. Now differentiate b into p square. B is a constant, no? B means y coordinate of the given point. That is fixed, constant. Now variable is p square. Now differentiate it. So that what do you get? B into 2p you will get minus. Now what do you do? Next we have to write u as it is, b into p square, and differentiate the denominator. We know 2 into p minus 2a. 2a is a fixed value. So whose differentiation becomes 0. 2p. We are doing with respect to p, no? Hence differentiation of 2p will be 2 will come, because the differentiation of p 1 and 2 will be left here by now. Okay, v square. V square means 4 of p minus a whole square. In the next step, what do you do? Okay, equate this first differentiation must be equal to 0. On equating this one equal to 0, what we people are going to get? Now shift this one to the right side. 0 into something? 0. Here 2 2s are 4. 4 into bp of p minus a. Now here when you, okay, this we transfer to the right side. 0 into something? 0. Now shift this one to the right side. 2 into b into 2b into p square. P square can be written as p into p. Now here 2 cancel, bb cancel, pp cancel. Now here 2 1s are 2 2s are. Now what is left side? 2 of p minus a. Now right side p. Now here simplify 2p minus 2a, which is equal to p. So here shift, transfer this p to the left side, so that 2p minus p will come. Now take this 2a to the right side, so that you will get plus 2a. Now p value you got now, p is equal to 2a. Now this p equal to 2a, students, substitute in this area function. Wherever P is there, there what you have to write? 2A. So if you write in the place of area function, area you got this much no in terms of P. P is a variable no. So here, what we are doing? We are keeping P equal to 2A. How it is generated, you came to know. We made first differentiation equal to 0 so that you got P equal to 2A. This is known as critical value in the differentiation concept. What do we say P value? Critical value. Actually, usually we go for second differentiation. For this, if you do the second differentiation, it will be positive you will get. Whenever the second differentiation is positive, then we say, okay, at critical values, that given function will be minimum. You know that concept. Here I did not go for second differentiation. Directly I equated first differentiation equal to 0. So that I got P equal to 2A. Now this P equal to 2A, substitute in the place of P in the area function. Now right there, A is equal to B into, so here P square means 4A square whole by 2 into, tell me students, 2 into P minus, so here P equal to 2A no, 2A minus A, 2A minus A. Now simplify that. A is equal to 4B, A square can be written as A into A by 2A minus A. Now denominator 2A will be left. 1A cancel. Now 2 ones are 2 2s are. 2 ones are 2 2s are. Now what is left here? 2AB. So 2AB square units. So this is our required minimum area of that triangle, which is formed by a line passing through a point A comma B with coordinate axis. 2AB square units, where A is what? Abscissa of the given point. What is B? Ordinate of the given point. Just multiply 2 into abscissa of the given point into ordinate of the given point, so that you will get minimum area of that triangle formed by a line passing through a point A comma B with coordinate axis. Okay, thank you.